This is lesson 9.3, rotations, starting on page 643. Number 3, triangle DFG has vertices -2, 6, 2, 8, 2, 3. Graph triangle DFG and its image after a rotation of 180 degrees about the origin. So we'll start by plotting the pre-image. So D is at -2, 6. F is at 2, 8. Excuse me. And G is at 2, 3. So we'll connect our vertices for the pre-image. And then when you rotate 180 degrees about the origin, the rule is XY will map onto opposite of X, opposite of Y. So the image of D, since this is at -2, 6, now it will be at 2, -6. So I'm rotating it 180 degrees in this direction around this point. So F, the pre-image is 2, 8. So now we'll be at -2, -8. In the image of G, instead of 2, 3, now we want -2, -3. And connect your vertices for your image. For number 11, find the angle of rotation to the nearest tenth of a degree that maps P onto P prime. Explain your reasoning. So based off of the diagram on page 643, we would be able to rotate it 120 degrees counterclockwise, and P would map onto P prime. And my explanation for this is that 360 divided by 6 petals equals 60 degrees per petal. And 2 petal turns is 2 times 60. Number 13 in our diagram, to map P onto P prime, we would want a rotation of 154.2 degrees. Counterclockwise. And to get this result, it would be 360 divided by 7 petals equals 51.4 per petal. And there are 3 petal turns, so 3 times 51.4. For number 15, graph each figure and its image after the specified rotation about the origin. So rhombus WXYZ has vertices given, and we want to rotate it 90 degrees. So if it just says 90 degrees, it actually means 90 degrees counterclockwise, so going in this direction. So we'll go to our graph and plot our pre-image points first. So W is at -3, 4. X is at 0, 7. Y is at 3, 4. And Z is at 0, 1. So connect our vertices for our pre-image, and we're rotating it 90 degrees, so 90 degrees counterclockwise about the origin. So we're rotating it around this point right here, going in this direction. And the rule for that is that XY will map onto opposite of Y, X. So for W, if our coordinates start off at -3, 4, then that would map onto, so I keep my X coordinate the same, but then I make it my Y coordinate. So my Y coordinate is now -3. And my Y coordinate I want to take the opposite of and make it my X coordinate. So now take the opposite of this, so that would be -4, and that's now my X coordinate. So opposite of Y, X. And do the same for the others. So X is originally 0, 7. And that would map onto, so once again, take your X coordinate and make it your Y coordinate. And then take the opposite of your Y coordinate and make it your X coordinate. So opposite of 7 becomes my X coordinate. So Y is 3, 4. So this maps onto my X coordinate becomes my Y coordinate. Take the opposite of the Y coordinate and that becomes your X coordinate. And 0, 1. So X coordinate becomes the Y coordinate. Opposite of the Y becomes the X. So then plot these points. So W prime would be at -4, -3. And X prime at -7, 0. Y prime at -4, 3. And Z prime at -1, 0. And connect the vertices of your image. So once again, I'm rotating it this direction around this point. So from here to there, 90 degrees going this way. 17, rotate trapezoid ABCD 180 degrees. So let's first plot our pre-image. So A is -7, -2. B is -6, -6. C is -1, -1. D is -5, 0. Connect your vertices. So then we're going to rotate this 180 degrees. So the rule for 180 is that xy will map onto opposite of x, opposite of y. So if A is at -7, -2, take the opposite of both of those, and you'd have 7, +2 for A prime. B is -6, -6, which becomes 6, 6. C is -1, -1, which becomes 1, 1. D is -5, 0, which becomes 5, 0. So, once again, we are rotating 180 degrees. So, if these were the hands of a clock, we're rotating around the origin. So my clock hand would end up over here if I'm rotating it 180 degrees. 19. Rotate parallelogram MPQV 270 degrees, and once again it doesn't state clockwise or counterclockwise, so we just assume it means counterclockwise unless otherwise stated. So plot your preimage points at M, -6, 3, P, -2, 3, Q, -3, -2, and V, -7, -2. So the rule for 270 degrees is that xy maps onto y opposite of x. So connect your vertices for your preimage, and then so M, the preimage is -6, 3. So following this rule, I just want to take my y coordinate and make it my x coordinate. And then I want to take the opposite of the x coordinate and move it to the back, so make it the y coordinate. So take the opposite of this, which would be 6, and now that is my y coordinate. So do the same with the other points. So P, which its preimage is -2, 3, and that would map onto, so my y coordinate becomes my x coordinate, the opposite of the x becomes the y coordinate. Q is -3, -2, and this maps onto my y coordinate becomes my x coordinate, and the opposite of my x coordinate becomes my y coordinate. And V, -7, -2. My y coordinate becomes my x coordinate, the opposite of the x coordinate becomes the y coordinate. And now I plot my image. So M is at 3, 6, M prime, P prime is 3, 2, Q prime is negative 2, 3. And V prime is negative 2, 7. And plot or connect your vertices of your image. And so what we can see here, so we're rotating around this point. We're going in this direction, counterclockwise. And imagine the hands of a clock. So then I would rotate to here would be 90. And now I'm at 180. And then, whoops, sorry, a little glitch there. So I'm rotating 90, 180, all the way to 270. So my hands of the clock would rotate from here to here, going in this direction, 270 degrees. In 21, the photograph of the Grand Rue, or big wheel, at the right appears blurred because of the camera's shutter speed. The length of time the camera's shutter was open. The diameter of the wheel is 60 meters. Part A, estimate the angle of rotation in the photo. Hint, use points A and A prime. So we want to estimate the rotation from this point to this point. So we want to find out how many increments of that there would be in this entire wheel. So if we count starting from here, that would be 1, 2, 3, 4, 5, 6, 7. And if we continue to count in that manner all the way around, there would be 36. So the entire revolution is 360 degrees. So if we take 360 divided by 36, then that means that each increment is 10 degrees. So once again, I'm taking the entire revolution, dividing by how many increments there are, which is 36, and then that gives me what each increment is, which would be 10 degrees. So estimate the angle of rotation in the photo, 10 degrees. Part B, if the Ferris wheel makes 1 revolution per minute, so 60 seconds, use your estimate from part A to estimate the camera's shutter speed. So 10 degrees would be how much of the entire revolution. The entire revolution is 360, so 10 is how much of 360? Well, then that would just be 1/36. So in our diagram, once again, from here to here, that would be 1/36 of the entire revolution. So if the entire revolution is 60 seconds, then we want 1/36 of 60 seconds. So 1 divided by 36 times 60 is approximately 1.7 seconds.